The final countdown is on. The interstellar object Ra-3I Atlas is not just an astronomical curiosity anymore. It is the most closely scrutinized mystery traveler in the history of deep space observation, and it is making its final spectacular swing toward Earth. The media might focus on its closest approach to the Sun, its perihelion, but for us, the real event is its gravitational slingshot past our planetary neighborhood. Every kilometer it shaves off that distance brings our high-powered telescopes, the Hubble, the Webb, and the world's ground arrays, within a razor-sharp resolving power needed to definitively settle the debate. The closer it gets, the more it is forced to operate under the constraints of our Sun's intense magnetic fields and radiation, and the weirder its behavior becomes. Its straight-line jets, its structural resilience against solar chaos, and its impossible density paradox are not diminishing. They are intensifying, or becoming sharper, more inexplicable visual statements. The universe just delivered a foreign engine right to our front door, and we have only a fleeting window to figure out how it works before it slingshots back into the interstellar void forever. Chapter 1. This is the peak performance window, the moment astronomers have been anticipating for months. The entire global network is synchronized, focused on capturing the object's behavior at its perihelion, its closest approach to the Sun, and its subsequent closest pass to Earth. While 3I Atlas never poses a threat, its proximity to the Sun triggers maximum sublimation, meaning maximum activity, and therefore maximum visual data. This is the moment when the object's internal engine, whatever it is, must be running at peak capacity. We are using the Sun as a cosmic stress test simulator. The increased solar radiation, the intensified solar wind, and the stronger localized magnetic field lines provide the most challenging environment for the object's supposed ice ball constitution. A simple comet should be tearing itself apart in a blaze of glory right now, succumbing to the chaotic forces. But 3I Atlas isn't doing that. It is maintaining an almost chilling composure. The precision of its straight jets, instead of becoming blurred by the increasing turbulence, is actually becoming more defined, like a laser beam cutting through smoke. This incredible stability under pressure is the first new piece of evidence confirming its unnatural structural integrity. This closest approach is our single best shot to lock down critical data points: the precise velocity vector of the ejected material, the exact composition of the deep core material being vented, and most importantly, the object's true mass. The fleeting hours of this final approach hold the key to a truth that has been hidden for billions of years. The window is closing rapidly. Every minute is a high-stakes capture of data that will either confirm a rare, bizarre natural phenomenon or prove the existence of something built to navigate the stars. Chapter 2. The closer 3I Atlas gets, the more pronounced its mass density defiance becomes. We are facing a paradox. If 3I Atlas is the size our instruments estimate, and it is composed of typical cometary ice and dust, it should have a specific measurable mass, and its trajectory should be perturbed easily by non-gravitational forces. But the straight jets and the high-speed material ejection require a rigid core to maintain the plumbing and contain the pressure, suggesting a high-density, metal-rich interior. If the core is metal-rich and dense, the overall mass of the object should be much higher, yet its observed gravitational influence on its trajectory does not fully align with the expected mass of a massive rock core. This discrepancy forces us into a corner. Is the object denser than we can fathom, or is its rigid structure incredibly light, yet somehow stronger than steel? This density paradox is the hardest piece of data for the natural model to reconcile. It challenges the fundamental assumption that mass and density correlate with structural resilience. It's as if the object is structurally armored, but internally hollow, or perhaps the density is confined to a perfectly symmetrical, hyper-compact core, a singularity of strength. The refined measurements being taken now are specifically looking for tiny gravitational nudges as 3I Atlas interacts with the Sun's magnetic field and our own planetary gravity well. Any subtle deviation from a pure ice model trajectory will solidify the case for a heavy, differentiated, and unnatural core. The closer approach is the final test of its true mass identity. Chapter 3. The intense solar radiation at perihelion should trigger a state of thermal chaos in a natural comet. As the Sun's energy increases exponentially, the surface of a porous ice ball should experience widespread simultaneous sublimation, resulting in a sudden catastrophic increase in outgassing. A chaotic burst that would obliterate the object's fine jet structures. Yet, 3I Atlas is maintaining its cool. The precision and narrow focus of the perpendicular jets prove that its thermal shield is working flawlessly, channeling the massive influx of solar energy and preventing uncontrolled sublimation across its surface. This shield is not passive, it is an active mechanism of thermal management. The shield must be thick, highly insulating, and incredibly resistant to the erosive power of the intense solar wind. The lack of chaotic outgassing suggests that the shield is not simply a layer of dark dust. It's a high refractory composite capable of enduring temperatures that would vaporize most common planetary materials. The efficiency of this shield is a testament to sophisticated engineering. It is routing all internal pressure to a select, structurally maintained set of nozzles. The object is not reacting chaotically to the sun, it is responding to the sun in a perfectly controlled, measured manner. The heat is proving the design. Chapter 4. The increased solar intensity at this proximity is having a unique effect on the jet structure. It is demonstrating the perfection of the nozzle effect. As the sublimation pressure inside the rigid channels increases due to the intense solar heat, the resulting high-speed gas is forced through the non-eroding internal nozzles with even greater power. This translates visually into jets that are now sharper and even more intensely collimated than they were further out. The geometric clarity is scaling perfectly with the energy input. If the jets were caused by random cracks, the high pressure would widen those cracks, causing the plumes to broaden and blur. Instead, the plumes are maintaining their near-zero deviation focus, confirming that the internal structure is not just resistant, but dimensionally stable under extreme dynamic loads. This perfect scaling is the definitive visual proof that the object contains high-tensile internal conduits, kibars. We are essentially looking at the output of a rocket engine or a carefully regulated thruster, where the material and structure can withstand immense internal forces to maintain the desired flow profile. The jets are not just lines, they are vectors of control. They defy the chaotic spread of natural cometary vapor, insisting on a fixed, unwavering path. The closer we get, the more compelling the visual evidence for an engineered channeling system becomes. Chapter 5. As 3I Atlas approaches, the increased heat is stripping away the outermost layers of volatile material, allowing our refined spectrometers to sample the true chemical fingerprint of an alien star system. The initial detection of nickel without corresponding iron was already a massive red flag, defying standard solar system condensation models. The latest spectroscopic measurements, taken at this point of maximum activity, are now detecting highly ordered, complex silicates and exotic carbon compounds that require formation under specific high-pressure, high-temperature conditions that are simply incompatible with a weakly formed ice ball. These chemical anomalies strongly suggest that 3I Atlas originated from a planetary system fundamentally different from our own, possibly one where massive, high-gravity worlds compacted materials into dense, chemically pure forms before the object was ejected. The object's material signature is screaming, "Alien geology, huh?" We are now actively searching the spectra for the missing iron, the element that should be present alongside the nickel. If it is detected, it would likely be found deep within a dense, differentiated core, confirming the object is not a homogeneous snowball, but a structured, multi-layered body. The chemical signals are becoming cleaner, richer, and more profoundly strange. Chapter 6. The non-gravitational acceleration of 3I Atlas, which previously was a subtle push, is becoming more pronounced as it nears perihelion. This acceleration, coupled with the straight jets, forces us to conclude that we are observing active flight path control. The straight jets are not just passive outgassing, they are intentional thrusters. If the jets were mere exhaust, the object's rotation and the solar gravitational pull would make the acceleration erratic and difficult to predict. Yet 3I Atlas maintains a surprisingly smooth, calculated velocity increase. This suggests that the object's internal stabilization system, the mechanism preventing the precession failure, is also modulating the thrust from the jets to achieve a precise intended acceleration curve. This implies an internal system of throttle control, a means to adjust the rate of expulsion from the channels to achieve a desired kinematic outcome. This level of dynamic control over its own motion is the hallmark of a navigational system, not passive physics. The object is using its internal energy and rigid structure to overcome the sun's gravity in a measured, predictable way. This active flight path control is the clearest evidence that the object is not just surviving the cosmos, it is navigating it. Chapter 7. High-resolution radar and optical mapping from the Hubble and Webb telescopes are now providing the most detailed view yet of the nucleus shape, revealing unnatural nucleus geometry. The shape is not the lumpy, potato-like aggregate typical of comets that have suffered impacts and erosion. Instead, the nucleus appears to maintain a high degree of geometric symmetry, possibly even a regular elongated cylinder or spheroid, hinting at formation processes far more controlled than chaotic accretion. The subtle irregularities that are present appear to be precisely where the jets originate, suggesting they are purpose-built apertures, rather than random surface vents. The smoothness of the non-jet emitting areas reinforces the theory of a robust protective external shield. The structural integrity suggested by the smooth, high-symmetry shape is impossible to maintain for a porous, volatile body undergoing extreme thermal cycling. The visual mapping is confirming the structural predictions made by the jet behavior. The exterior is a uniform envelope protecting the internal mechanisms, proving the object is not a random chunk of space debris, but a structurally deliberate body designed to resist the forces that typically reshape and destroy comets. Chapter 8. The fact that all these anomalies, the jet perfection, the acceleration, the structural defiance, are intensifying precisely at the perihelion threshold, suggests a theory of intentional activation. why would an interstellar traveler from another star system only become fully active when it reaches the inner, high radiation zone of our star? One chilling theory suggests that 3I Atlas possesses a built-in proximity sensor or energy threshold system. Hot. Perhaps the object was designed to remain in a stable, dormant hibernation state until it reaches a specific level of stellar magnetic field strength or radiation intensity, the precise conditions of the inner solar system. This activation could be a deliberate action, a necessary thawing process, a recharge cycle, or even a pre-programmed attempt to communicate or gather data in an energetic environment. The rapid escalation of its complex behavior right now suggests the core system has just reached its operational status. The timing is too perfect to be coincidence. The object is not passively reacting to the sun, it is responding to a trigger. Hashkarsased. This suggests a complex internal logic dictating its visible behavior based on external local physics. Chapter 9. The wealth of clear visual data coming from 3I Atlas is now being used to retroactively analyze the first interstellar visitor, Oumuamua, effectively eclipsing the Oumuamua precedent. Oumuamua was famous for its non-gravitational acceleration without visible outgassing, forcing astronomers to invent the invisible hydrogen ice theory. Now, with Atlas, we have definitive visual evidence of a geometrically perfect, high-velocity expulsion mechanism. The comparison argues that both interstellar objects share a lineage of controlled expulsion and structural integrity, finally discrediting the passive iceberg theories. Atlas's clear evidence of plumbing, propulsion, and stabilization systems suggests that Oumuamua was merely a slightly different model, one where the propulsion mechanism was internalized and entirely invisible. Atlas is forcing us to see the cosmos differently. The final data collected in these crucial hours will finally uncement its place in history, not as a comet, but as the clearest visual evidence yet that the cosmos is far more populated by complex, highly resilient structures than we were ever prepared to believe. The mystery is over. The new reality has begun.